All right, good afternoon. Okay, you can hear me. And yeah, hi, my name's Ian. I'm gonna be here to tell you some ways to save money on your AWS bill, which I'm sure everyone's gonna be happy about that. So I've been doing this AWS serverless thing for quite a long time. Been running stuff on AWS since 2010. Nowadays, I lead a double life. One life, I'm working as a developer advocate for Lumigo. I'm going to talk a bit more about them later. The other half of my time, I work as an independent consultant where I help other companies adopt serverless and work out all the different pitfalls to avoid and so on. Along the way, I collect lots of different tips on how to, save money on your AWS bill by identifying waste and removing them. And so I hope you enjoy drinking from the fire hose, because I've got a bunch of ideas for you to think about and hopefully take away back to work. I'm going to start nice and easy. Something that everybody should be doing today. In fact, the first thing you do when you open an AWS account should be to set up your billing alarms. So got something that everyone should be doing. And yes, billing alarms are not perfect. They are a few hours behind, but it's much better to find out you've got a problem a few hours late than to say a few weeks or months late. And we've got a really good story here from Luke from PostNL. PostNL is basically the Dutch equivalent of Royal Mail. So they had this very interesting thing happen to them where they made a one-liner change which broke caching. So instead of getting some secrets from Secrets Manager on cold start and then caching it, they were going to Secrets Manager on every single invocation. And when you're doing millions and millions of invocations every month, so those costs grew pretty quickly. And with the billing alarm in place, they were able to find out that they got this issue going on when they got the alarm in about 2 weeks into the problem. But if they didn't have the billing alarm, then imagine they're going to wait weeks or maybe months later until the finance department came knocking on the door and say, hey guys, we noticed we are spending about $5,000 a month on your AWS account, whereas before it was $50. So what's going on here? And the morale here is that, yes, they are not perfect, but you should use billing alarms nonetheless, because it's still going to save your ass when you find out there's a problem in a few weeks as opposed to much, much later in your cycle. But when it comes to cost, probably the number one item I see on my clients' AWS bills is typically CloudWatch. Much more than, say, the cost for your API gateway and your Lambda functions. CloudWatch normally is in the top 3 in terms of the billing items on that AWS bill. And the worst thing is that the more data you collect, the more money you pay, the value gets lower because you have a much bigger haystack to look for those tiny needles when you do have a problem. So when it comes to keeping your CloudWatch logs cost under control, there's a couple of things I like to do. First one is something that you should be doing always, which is to use structured logging so that you can, for every single log message, say what log level this message should be recorded as, so that not everything is going to be important for debugging. Some stuff are things like warnings, so that these are problems, but they don't stop, say, they're not going to crash the request. And the things that are going to be crashing your request, you can record them as error. Importantly, once you've got the different log levels set up correctly, then in production, you can say, don't log any of the debug messages so that you don't have this massive volume of data that you're collecting all the time. But those debug messages are really useful when it comes to debugging, troubleshooting production issues, so you don't want to have none of them either. So typically what you do is you will sample those debug log messages so that, say, for about 5%, 10% of invocations, enough so that you've got debug log messages for every single code path you have in your application, but not so much that you end up paying a huge amount of cost when it comes to CloudWatch to have all of those debug messages and then having to find some way to process and query them. And lastly, make sure that you set your log retention to something more reasonable. When it comes to logs, the longer time goes by, the less value you're going to have for those log messages. And by default, CloudWatch logs is set to never expire. So they don't want to delete your data without you saying so, but it's in your best interest to set some reasonable retention policy for your logs so that you don't end up paying that 3 cents per gigabyte of data every single month forever and ever. Another thing that I often see is that the people don't use CloudWatch to actually query the data. They want to send the data from CloudWatch to some other third-party provider where they have a better UX or developer experience for working and querying your logs. So in that case, you still end up having to ingest the logs in CloudWatch first, and you're going to pay 50 cents per gigabyte for the data ingestion, and then you have to pay for the processing of those logs, and you pay for the storage and processing on the other vendor side of things as well. So you end up paying for the same processing and retention of the logs twice. I don't mind spending money on things, but I want to get some value for it. What I really don't like are waste, things that I'm paying for that doesn't give me any value. So nowadays, if you want to ship your Lambda logs to somewhere else, to a different vendor, you should use the Lambda's Lambda extensions with the telemetry API instead, which extensions are basically kind of like a sidecar process. You can run side by side with your Lambda application, and you can use the telemetry API to subscribe to logging events and the metrics events and so on. So you can then send them straight from the Lambda extension to the third-party vendor, bypassing CloudWatch logs entirely. But by default, it doesn't actually sidestep the Lambda's, Lambda will still ship the logs to CloudWatch. So what you do is add this little block to your IAM policy for the Lambda function. So Lambda no longer has a permission to write stuff to CloudWatch logs. And so you don't send data to CloudWatch and you don't pay for those data because you're sending them straight to the third-party vendor instead. And if you're looking for a different vendor, and Lumigo does the logging ingestion as well at a much cheaper rate compared to CloudWatch. And also, once you've got the data, you can set up you can aggregate data on demand and then create the custom alarms with no extra cost, because they only charge you for the ingestion of the logs, not for how you turn them into alarms and so on and so forth. Another thing when it comes to logs and Lambda is that you get these system messages. So every invocation will have information about the version, when it started, when it ended, a report of how much time was you had and how much time you were charged for. For 99.99% of people that are using Lambda, this is not going to be a problem. But if you're doing billions of invocations every month, like the guys with Thoughts Analytics, those system messages alone can actually amount to a non-trivial amount of cost when it comes to CloudWatch, because again, you're paying for ingestion, you're paying for storage as well. So nowadays, you have the advanced logging controls with Lambda so that you can set the logging config on your Lambda function. And I don't like the fact that the two couple of things are tied up together here. When you set the log format to JSON, Lambda is going to take whatever you write to standard out or standard error and put them into a really simple JSON format so that you've got structured logging, kind of structured logging. But the important thing is that once you change the log format to JSON, you can now use the system log message, system log level to control which of the log messages Lambda is going to output to CloudWatch. I couldn't find the table of which messages are tied to which level, so I did some testing myself, and I found that these are the kind of mapping of the system messages to the log levels. So if you only want to see when there's an unhandled exception and it blows up your application because something happened out of memory, for example, then you can just set the system log level to 1, so you still get those error messages, but everything else you can rely on your application level logging to catch any problems with your application code instead. So staying with Lambda, we can talk about probably the one of the main ways you can kind of right-size and optimize the cost for your Lambda functions, which is right-sizing the memory setting. Because with Lambda, more memory also equals more CPU power and also more network bandwidth as well. And you can really easily increase the amount of memory you have for the function, which also going to give you more CPU powers. And once you go over 1.8 gig of memory, you also start to unlock a second and third and fourth virtual CPU core as well. But the amount you pay per millisecond of execution time is also tied up to the memory setting as well. So the great thing is that you now have a really easy way to add more power, give your function more juice to do more stuff, but you can also get that setting wrong by orders of magnitude very easily. And this happened to one of my clients I was working with a while back. So they do video rendering, those kind of a hand-drawn video style things you probably see on YouTube quite a lot. And the team there knew that by giving the Lambda function more memory, you're going to unlock more CPU power. However, they didn't realize the fact that the more CPU power only goes up to 1.8 gig. After that is multi-core. And to take advantage of multi-core, you have to write your application in a particular way to do that, right? So they were using Node.js, which means that you're tied up in an event loop. So by default, you only use one CPU core. And you have to write your application in a particular way to use workers or what have you to then unlock parallel processing and unlock the use of multiple cores. They weren't doing that, so they maxed out the Lambda memory setting to 10 gig, so they were getting all the 6 CPU core, but only using one of them. So again, I don't mind paying money for stuff, but I want to get value for it. And for them, they were wasting basically 70% of what they were paying for, which is not great. And for us, we basically decide, do I rewrite the application to use multi-core, or do I just set the memory setting to 1.8 gig and save 70% of the cost And basically, this happened to them on one Lambda function out of hundreds of in their system. And one function basically was counting for about $10,000 a month on the AWS bill, because again, they were doing this fairly high volume stuff, and every single function, every time it runs for a good 5-10 minutes. But the problem is not the fact that it's expensive. The problem is that most of that money they were spending on was being wasted. As the great Don Knuth said, we can ignore small efficiencies for about 97% of the time, but we shouldn't pass up opportunities for that critical 3%. Again, when it comes to identifying where your critical 3% is, Lumigo has got a really good UI that shows you the estimated cost for your Lambda functions, so you can very quickly identify maybe you have got 1 or 2 functions where you account for a large percentage of your cost. Personally, for most of my clients and most of the Lambda functions I've seen, there's such a low cost when it comes to Lambda functions. There's no value for optimizing any of them. You can actually just safely over-provision slightly, say slap 1 gig instead of the default 128 meg, which SAM and CDK and a bunch of other tools defaults to. Just forget about it, because there's no point trying to optimize and save a fraction of 0.1 cents or whatever. So identify where it's worth spending money and time to optimize your functions, and then only optimize those functions. And once you've identified that critical 3%, the way you optimize your Lambda functions in terms of right-sizing the memory setting, the best way to do that is using the Lambda power tuning tool from Alex Casaboni. Basically, it's a step function state machine that takes a function, you provide an input, and it's going to create several versions of the same function with different memory settings. And then it's going to run the same function multiple times against different memory settings and give you a graph to show you that, okay, as you add more memory, while performance is going to improve, the latency is going to go down, but then your cost is also going to go up at some point, because you start getting better performance as you add more and more memory. Again, this is a Node.js example. So as you increase the functions to more than 1.8 gig, you're not going to get any performance benefit until you rewrite the application to take advantage of multi-core. Another good way to kind of save money on your Lambda cost, again, for those specific 1 or 2 functions you may have, is to use ARM. So ARM, compared to x86, is 25% cheaper per millisecond of execution time. And so if you've got something that runs often, then the ARM can potentially just give you a free saving of 25%. But it's important to test your specific workload against different CPU architecture. For my own test, some of my functions are up to 60% slower on ARM than x86. So if I'm saving 25% per millisecond, but spending 60% more time, overall, I'm spending more money on those Lambda functions. So again, it may be a good way to save money on your Lambda functions, but find out if it's actually going to be performing in a relatively similar terms to x86. What it's really good for is when you have got a lot of I/O wait time. So this might be a case for me. On a previous project, we did a lot of integration with Salesforce. And one thing I learned about Salesforce is that the APIs are so slow. So like I've got API calls that sometimes take 50 seconds to respond, which means 50 seconds of I/O time just wasted. So in that case, ARM is a really good way to just take 25% savings on those I/O time that I'm wasting. When it comes to Lambda, probably the biggest anti-pattern is having synchronous Lambda to Lambda calls. So I want to spend quite a few minutes on this. When it comes to Lambda functions, every single function, doesn't matter how you call it, you use it, has to go through the invoke API call. And when you invoke a function, you specify what's the invocation type. It can be a request response. So you start invocation, the API call doesn't come back to you until the whole function is finished running. So you get the response and the output and the logs and all that. Or you can do this find and forget thing so that you can invoke the function and set the invocation type to event, which means Lambda API is going to accept your request. It's going to return to you straight away. You can go on and do other things while the function is going to process it behind the scenes. You don't have to use SNS or EventBridge to get async invocations for Lambda functions. You can just invoke the API yourself and set invocation type to event. So synchronous versus asynchronous invocations for Lambda functions, important distinction to remember, because when it comes to synchronous Lambda to Lambda calls, so you calling another Lambda function from one function is pretty much always a bad design. For one thing, when that first function calls the second function synchronously and wait for a response, you are paying for the duration for both functions. So again, you're double paying. There's also other issues as well. We're going to talk about that in a minute. But when it comes to, say, within the same boundary context of microservice, we talked about boundary context earlier. If you've got two functions doing two different things, one calling another, just so that you can have some modularity and some decoupling, whatnot, stop that. Just take whatever you're doing in two functions, put them into a single function. You can still have modularity inside your code. I mean, these things are called Lambda functions, but you don't have to think of them in the same way you think about Lambda functions in just programming. You can still have modularity in your code, how you structure your code, but you don't have to separate things into separate Lambda functions just to get modularity. Okay, so that's what happens when you've got multiple functions in the same boundary context. What happens if you've got, say, different services, you want to expose capabilities to each other? What about when you have Lambda to Lambda calls across the service boundary, across the boundary context? Is that a good idea? Absolutely not. It's probably even a worse idea than before, because now you're tying your callers to specific implementation details that you've decided. The fact that you're using a Lambda function, the fact that you call this function hello world 1, 2, 3, and the fact that you're running in a particular region, particular account, those are all things your caller shouldn't have to depend on to be able to use your service. So if you're going to expose some capabilities to a different team, someone else to use, then just give them HTTP interface. So this could be API gateway, it could be ALB, what have you. And behind the scenes, you can evolve your application from using Lambda to start off with and say, okay, until you get too expensive, because we are doing now millions of requests and thousands of requests per second. So let's move that workload to Fargate, to containers, where we're paying uptime as more efficient at scale. You can do that, you can make that change without having to affect your callers, because they're not depending on the Lambda function anymore, they're just calling API. So an HTTP API is a much more stable interface for other teams to depend on, as opposed to implementation details about the fact that you're using Lambda or containers or whatnot. So that's synchronous Lambda to Lambda calls. What about asynchronous Lambda to Lambda calls? So this is kind of interesting, because I have got couple of use cases where I found in the past where this is actually a really nice pattern. When I've got user-facing API functions that are doing something, so for example, user wants to update their profile, and I've got an API for that, and I've got a Lambda function to handle that. But once I've updated the user profile in the database, that's my primary responsibility. I also want to do other things. Pixel tracking, want to call some other services, update this event, and so on and so forth. I can do that in the first function and add delay to user getting a response back. But more importantly, when things doesn't go well, when that call to that third-party service blows up, I don't want the user-facing API function to blow up either. So what I can do is offload that secondary responsibilities to a second function, which I'm going to invoke asynchronously. So the first function, just invoke the function, the second function, and get a response back straight away. So then you can start to respond, so that you can respond to the caller. And this way, I can reduce the user-facing latency and improving user experience. And also, more importantly, when it comes to error handling and resilience, it allows me much more flexibility to implement retries, which I get out of the box, because for async invocations, you're always going to get 2 retries out of the box from Lambda, and also you get exponential backoff and DLQ support as well. So I can be much more flexible in terms of how I do error handling when I do those non-critical or secondary responsibilities inside a second function. So this is with the assumption that those functions are in the same service boundary, because there are things that I would have done in that first user-facing API function already, but I'm just separating things out so that I can have that better user handling or error handling and so on and so forth. If you've got async Lambda calls across service boundary, again, not a good idea for the same reason that you don't want people to depend upon the implementation details that you're using a Lambda function on the other side of the service boundary. So async Lambda to Lambda calls, is that a good idea? Depends on some specific use cases where I think it's actually a really nice pattern to have. But my rule of thumb when it comes to architecture is that, well, one of the rule of thumb is that when I look at my architecture diagram, I want to make sure that everything that's on there serves a purpose, is giving me some value, because every single component has a cost in terms of complexity, but also in terms of cost for AWS resources I'm using as well. So if I'm getting some value from that, having a second function, I'm paying for invocation requests and all of that, but I'm getting some value by allowing me to improve the user experience or improving the way we do error handling, then that is fine. But if I'm just doing something because that's something we always do, then probably need to rethink how we do things. Another good way to save cost on your AWS bill is to implement the effective caching strategy. And when it comes to serverless and your typical APIs and so on, there are just so many different ways you can implement caching. And for me, caching is almost like a cheat code when it comes to building scalable but also cost-efficient applications, especially in the cloud. So if you look at your typical serverless API, I can have your typical client talking to APIs through CloudFront and then Lambda function behind it, DynamoDB, and so on. There's so many different ways I can implement caching, so many different places. I can do caching on the client side for basically assets or config files and things like that. And then for API responses, I can do edge caching with CloudFront. And if I've got some CPU-intensive stuff, I'm doing some calculations inside my Lambda functions, I can also do application-level caching with my Lambda function and maybe saving those computation results into Elastic Cache. But again, I think like Leah talked about in the morning, paying for uptime has got a cost to it. If you don't use it all the time, then a lot of what you're spending are being wasted. So I really like services that gives me pay as you go, so only for requests I'm using. So I'm a big fan of Memento. They've got a really solid, really scalable caching solution that you only pay for requests, you don't pay for uptime as well. Another form of caching that probably doesn't get talked about enough is Route 53. Route 53 charges you based on the number of requests, DNS requests you handle. And so depending on your TTL, which by default is 5 minutes, you may end up processing a lot more requests than you need to if I just set the TTL on the, say, stable domains that doesn't change very often. Just slap like a couple of days, couple of weeks, or even longer if you know your DNS is not going to change for those stable domains, and you can potentially cut down quite a bit of your Route 53 costs as well. And perhaps the biggest, cost savings strategy is actually look at your architecture and make sure that you're using the right services in your system. Because in the cloud, every architectural decision is a buying decision. By choosing which service you want to use, you're making a decision to pay and buy that service. And of course, AWS has got so many different services, many of which have got overlaps. And if I was to build something event-driven, I need a messaging service. I may look at EventBridge, SNS, SQS, Kinesis, and so on. At a really low throughput, Kinesis looks quite expensive because there's an uptime cost component to it. But then as you scale up to, say, 1,000 messages, suddenly the picture looks very different. Same goes to API gateway versus ALB as well. ALB has got a somewhat complicated way to calculate how much it charge you, again, based on uptime. And assuming a very small payload, ALB can be quite expensive at low throughput, but much more cost efficient as your scale goes up. However, a good rule of thumb to have, again, is that the services that charge based on uptime is going to be a lot more cost efficient when you're running at scale. But this is an important bit, because you always need to think about the specific cost dimensions for each service you use. Earlier, we used a calculation based on the assumption that you'll have a very small payload. One of the dimensions that ALB charges you is based on data processed. If your API is handling large blobs of data either as input or output, then suddenly the picture can look very different. Anyone want to take a guess how different? 1, 2, 3. Crazy level of difference depending on your actual use case. So don't just assume that something is paying by uptime, it's going to be efficient, cost efficient at scale for you. Always think about your specific use case. And that brings me to the frugal architect that we got from Werner a couple of years ago, and his 7 laws for architecting. I really like this, but this too, where architecting is a series of trade-offs, and that we should find the build systems that aligns its cost with the dimension that our business revenue is going to grow. So I built quite a few, WebSocket type things that requires some kind of WebSocket connection. Within AWS, you can have a serverless WebSocket with AppSync, API Gateway, IoT Core, and so on. All of them charges you based on the dimensions of number of messages you send and connection time. But if my system is such that as more users join, we have high connection time, but then our revenue doesn't grow along the same dimension, it grows along the dimension of engagement. The more stuff people do, the more likely they're going to convert, and the more we're going to grow our business revenue. So I want my cost to grow along with engagement activity, not just with idle connection time. So again, when it comes to picking the right partners to work with, I really like Memento and the WebSocket stuff they offer through topics, where they don't charge you for uptime, only charges you for the number of messages that you are processing and broadcasting and so on. So there's, of course, the Cloudflare durable objects as well. We saw in the morning, also a very, very cost-efficient solution. But yeah, Memento and other services that only charges by activity is a much more cost-efficient way to build WebSocket solutions. And speaking about picking cost-efficient services to partner with, I don't know if anyone remember this, happened a few months ago when a social network kind of blew up from no user to 500,000 daily active users or something like that. And then they got a $100,000 bill from Vercel because, Vercel is built on top of AWS. And so they have a massive markup in terms of how much they charge the customers. And in this case, I think we did some calculations and found that Vercel has got like a 7x markup or something like that compared to just using Lambda directly. So, of course, there's a cost involved with growing your service from no users to 500,000 daily active users. But how much you're going to end up paying can be significantly different. I'm actually a really big fan of Vercel in terms of the stuff they're doing, with the innovations they're doing. But when it comes to building something and potentially that's going to succeed and grow, do think about the different cost dimensions that they're going to throw at you, and they have very complicated cost dimensions as well. So to wrap up, 7 different ideas for how to reduce the waste. Not so much just the cost, but when it comes to reducing waste, you're also going to reduce the cost as well in your AWS architecture. You want to learn more about the building serverless applications for production. I also got a workshop coming up as well. Go to productionreadyserverless.com. If you've got any questions, just come find me afterwards. I'm going to be around for the rest of the day and happy to answer any questions you have. Thank you very much.